in this presentation, in this part of the session, we are presenting the user story too. Yorgos and Christian presented it. Presented it previously, and is regarding to pesticides use. So why we decide? Well, this is the agenda that I have in mind for this presentation. A little introduction on why we decided to go for this user story. Sorry, and the main components and actor we identified. We try to explain a little about the UML that Yorgos presented previously, and then we will present the potential indicators in the performance monitoring and evaluation frameworks from the CAP current programming period. So as for this, talking about why we decided to go for this user story, we think that what there is regarding to the regulation implemented by the Commission about plant protection products. Under this regulation, there are some key aspects. We bring here some of them. The first key idea is the scope and the timing. It was supposed to be compulsory from 1st of January 2027. The information to be recorded is this one we put here, the type of product that is utilized, when it was utilized, the dose, the quantity, the volume, and what it was applied. And this is very important because it's a georeference application. What is the crop it was applied in, and the stage of this crop. And there's additional parameters if we think about indoor treatments. So the second key idea, the third key idea here is that this record must be kept electronically and in a machine readable format. And there's last key ideas here is the timing, that the farmers need to communicate this information within 30 days after applying this information. So this is a key element because this timing is putting more pressure on their farmers. So that's why we decided to go for this user story. And this was supposed to be, as I said before, from 1st of January 2026, but last October the 2nd, the Standing Committee of Plants, Animal Food and Feed agreed to postpone the entry into force of 1 year of this regulation. So we have some space here for maneuver. And let's move on. Well, going into details on the main components and actor, Christian presented this idea we have for this user story, and we think that the farm management information system in this case have a central role. So we have this central part of the FMAS, and then we have several information coming in and coming out from this farm management information system that in the end can help to quantify somehow some indicators or some could help in the evaluation of the strategic plans. So the first part here is the data coming in the farm management information system. We call it off-farm data. For instance, we have the Earth observation data, and in this case, we think that the Earth observation data, data coming from satellite is I'm not sure if say mature enough because many farm management information system implement this collecting and presenting this type of data. So, but where we found a gap is in the use of data coming from agricultural machinery. So this machinery is capable to store many data from the practices that are taking place in the field, such as volume of pesticide use or yield collected. So we have many information in this regard, and the great majority of this machinery is equipped with positioning systems, GNSS systems. So not only we have the data itself, but we also have the position where it was collected. So this is very important. But on the other hand, we found here a gap because there is not a clear interoperability procedure to communicate this information to a farm management information system. There are some tries, but there is not a definite one. And we also have, regarding to pesticides, databases at national or at the European level that help us, the farm management information system, to know if this to collect data on the usability of this product for the crop they are being applied. So this is the first part. As moving on, we have the farm management information system, the central role in this user story. And in this case, we found the need of having a data translator that could integrate or enable the transmission of this data into the system, in the management system. Another key idea here is that in this farm management information system, is required the intervention of the farmers to collect or to enter the non-automatized information and record it with the adequate timing regarding the regulation. And the information that is collected in the farm management information system is a very valuable information for the farmers themselves and also for advisors that could give that could use them to perform a better advice to the farmer. So in the same direction, we found that this farmer management information system need a data translation and interoperable APIs to communicate this information with other actors. So that brings me to the next component, that is the consumers of this information. We found it here two different directions. First, the administrative databases that can take advantage of the information collected and transmitted by the farm management information system, and the statistical databases that are used in a more broadened context, let's say that. And the first one is more CAP related. So, for instance, we can think of the Ajax database that is used for control the requirements under the regulation. And as for the second one, the statistical databases, we can think, for instance, Christian mentioned previously about the FADN, FSDN databases that can support the computation of some indicators in the monitoring and evaluation framework. So keeping in mind this, we can think that combining all this information coming from different data sources could give us some information, could give idea on how the interventions implemented in the strategic plans are performing. So, but here we found that for this combination and extracting minimum meaningful conclusions, we need a combined expertise, personal expertise. So in this case is what we try to do in the case study. That is very linked to, quite linked with this user story. So I'm explaining a little the case study that is very related to this user story. The idea was to collect to use the data in the FMIS, the Farm Management Information System, and use it as input for agroeconomy model SCAPRI. So we performed this. We collected the information. We extracted the information from the FMIS provider database, and we use it in a CAPRI model in the field of the pesticides use. So we did this, and we found. Well, I'm not an expert in this. I'm not an expert in this CAPRI model, but this is one of some of the results we get from here. But the main idea here is that depending on the data you are using, you can get different results. So it's very important to have expertise or be an expert to integrate this data and the models, and also to interpret these results. So this is an example of how we use the data on fungicides application, and this is an example of the herbicides application on the traditional follow. Well, we found some. I put positive and negative, but I think it's our conclusions very valid both. So in the positive way, we demonstrate with this case study, we demonstrate the integration of this FMIS data in an agricultural model, in an economical model. So it's feasible. And we found that, as I said before, there needs to be an expert interpretation of the results. So we need, or we found the need of involve different profiles regarding the stakeholders. So we need involvement of stakeholders such as farmers unions that interpret in the right way these results. So as in the negative way, Georgios said something about this previously. It's the main idea here is the reluctancy of farmers to provide this data. This reluctancy comes, I think, from two different points of view. The first one is that they are feeling that it's not reducing that what it was supposed to reduce the administrative burden upon them is not reducing that, even is increasing it. So this is one of the sources of the reluctancy. And The second redundancy is the concerns about being punished about not compliance with the regulation. So somehow they just fulfill the requirements with the necessary information to just to move on. And the second idea is on the product registration, that there are many products that are not registered to be used for certain crops that in fact they are used for other crops. So there is a little gap here regarding the registry of the pesticides products. So going back to the user story, as Georgios presented, this is the UML diagram. Georgios explained it, how to read it, so I'm not going to details here. But we think that in this part, in the evaluation data and adjust CAP strategic plans, we found that the data coming from the farm management information system, and as for this programming period, we can find that there are some intervention that could be evaluated by using this type of data. For instance, in Pillar 1, we think that could help evaluating some eco schemes. And as for Pillar 2, we think that can be used for this other intervention, the investment, environmental and climate related and other management commitments, and knowledge exchange and dissemination of information. And mainly also on the statutory management requirements established in the Annex 3. That these statutory management requirements are compulsory for all the farmers, regardless they are applying for subsidy or not. So this is quite important. So in this case, we think that the main indicators that can take advantage of this information is the impact indicator 18 and the impact indicator 18 related to pesticides use. The result indicator, the 24, and also for the context indicator 49. So this is what we think that this information can be used. So sorry, and that's all for my side.